So what we're going to be talking about today is reading the graph of the derivative, okay? So that's going to tell us different things about the function, all right? So we know that f is increasing. So I'm going to write here f is increasing. And that would mean that f prime is greater than 0, okay? So if we're looking at the derivative graph, to see where f is increasing, all we have to do is look at the graph of f prime and see where it's above the x-axis, okay? Similarly, f is decreasing. So this means if and only if, okay? F prime is less than 0. To see where it's decreasing, we just have to look at the graph of f prime and then determine where it's below the x-axis, because that would be where the values of f prime are less than 0, okay? Now, let's talk about the graph of f prime. If f prime is increasing, okay, we could tell f prime is increasing, all right, and that would mean that f double prime is greater than 0, because one derivative away tells us whether it's increasing or decreasing, okay? So if f prime is increasing, so we're looking at the graph of f prime. If it's increasing, that's telling us f double prime is greater than 0, which in turn tells us something about f, and it would tell us that f is concave up, all right? Now, if f prime is decreasing, that would tell us that f double prime is less than 0, okay? So f one derivative way, that would mean it would be negative. And then since f double prime is negative there, then that would tell us that f is concave down. So my point of this is, if we look at the derivative graph, it can actually tell us where f is increasing and where it's decreasing. And it can also tell us where f is concave up and concave down, okay? All right, so this is the graph of g prime, and from the instructions here, the function g is defined and differentiable on the closed interval -7 to 5. Okay, so if it's defined, that means I have every single value of g. It takes on every value from -7 to 5, okay? And it's also differentiable, okay? The graph of y equals g prime of x, the derivative of g consists of a semicircle, that's this part right here, and 3 line segments as shown in this figure above. So here's my line segment, one of them, here's the second one, and here's a third one, okay? Now, they're telling you that g is differentiable, okay? G prime is not differentiable because we have corners at several different places, okay? So I want to go through this graph and figure out, okay, where is G prime 0, and also where is it undefined? So right here at -2, okay, this point, -2, 0, okay, that's going to be an important point, okay, because that's where the derivative is 0, okay? Same thing with right here. So the derivative is 0 at 2, 0 right here, all right? And then right here, okay, we got to figure out this value right here. So the way to do that, okay, and it looks like it's right in the middle, but you can't assume that, all right? We need to actually figure this value out right here, okay? So we can do that by writing the equation of this line. But to do that, we need to figure out the slope of the line. So my change in y over my change in x, I'm going to go -1 minus 3 for my change in y. So -1 minus 3 over 5 minus 3. Okay, so that gives me -4 over 2, which is -2. Using point slope form, I know that y is equal to -2 times x minus 3 plus 3. And then I want to know when y is 0. So I could set that equal to 0, y is equal to 0. And then that would be negative 2x plus 6 plus 3. Okay, so that makes 0's equal to negative 2x plus 9. That would mean 2x equals 9, which means x is equal to 9 halves, or x is equal to 4.5. So it was in the middle, right? But we didn't know that until we figured this out, okay? So this point right here is 4.5 comma 0. So that's where that's where the derivative is 0, okay, at every one of these, okay? So we want to know, okay, this first question, on what intervals is g increasing? And we want to justify our answer, okay? So to figure out where g is increasing, we need to know where g prime is positive. So g prime is positive from negative 2 to 2, but not at 2 and not at negative 2. And then all the way from 2 to 4.5, but not at 4.5. However, it continues to increase even in here, even though the derivative is 0 right here at 2 and at negative 2, okay? So our rationale for this would be g is increasing on, and it would be increasing the entire time, okay? So from negative 2 to 4.5. And the way we can determine that is because g prime is greater than 0 on the intervals. Now, we're not going to give it the same interval because now we're just saying we know this because g prime is greater than 0, but it's only greater than 0 in between negative 2 and 2. So we go negative 2 to 2 with parentheses, and then union 2 to 4.5. Or 9 halves. Okay, so that's how we justify that one. Okay, on what intervals is g decreasing? Okay, so determine where g is decreasing. We're going to look at the graph of g prime of x, and we want to know where g prime is negative. Well, it's negative from negative 7 to negative 2, and then from 4.5 to 5, right? But not at 4.5, but not at negative 2. But those points right there, we are going to include to say where it is decreasing, okay? So we would say g is decreasing on, and we would start it at negative 7 to negative 2, including both, union, and then 4.5 to 5, okay? And it's because g prime is less than 0 on the intervals. Now, it is less than 0 at negative 7, so we are going to include negative 7. But it's not 0 at negative 2, so we're not going to include negative 2. And then union, and we're not going to include 4.5 because it's not negative there. And then at 5, we are going to include because it is negative there. So we just have to give the rationale, we have to give where it's exactly negative, okay? All right, so then the next question is find all x coordinates at which g has a relative maximum. Okay, so that would be where g prime is changing from positive to negative, okay? And so where it's changing from positive to negative, we're using the first derivative test there, right? That it's changing from positive to negative at 4.5. So we know we have a relative maximum right here at 4.5. Now, g prime has a relative maximum right here at 3, but we're not talking about g prime. We're talking about g has a relative maximum at 4.5. That's normally you look at these and you look at maximums on the graph of g prime. Those will be maximums for g prime, not maximums for g, okay? So it's only at this 4.5. So we would say g has a relative maximum at x equals 4.5. Now we can't actually tell what that maximum is because we don't know anything about g. We can't get it, okay? But we say it's because g prime changes from positive to negative at x equals 4.5, period. Okay, I'm going to slide this up a little bit so we can see it a little bit better. I'm going to zoom in. Okay, now find all x coordinates at which g has a relative minimum. Justify your answer, okay? So for it to be relative minimum, g prime has to change from negative to positive, right? And so that's going to happen right here at -2. That's the only place where it's changing from being negative to positive. So g has a relative minimum at x equals -2 because g prime changes from negative to positive at x equals -2. Okay, so right here, it's changing from being negative to positive, so that's telling me we have a relative minimum right there. So right here, we have, we're on what intervals is g concave up? Okay, so to determine concave up, we have to look at g prime is greater, or g double prime. G double prime is greater than 0. Well, how do we know if g double prime is greater than 0? It's greater than 0 if g prime is increasing. Okay, so where is this increasing? Okay, so it's going to be increasing from -7 all the way to 0, and we're going to include that. Okay, so that's where it stops increasing. This is where it starts increasing. Okay, it's also increasing starting at 2, going to 3. Okay, and those are the only places, all right, it is increasing. Okay, so intervals where g is concave up. So we would say g is concave up on the interval -7 to 0, including both, and then union 2 to 3. Because, and you have to give a justification why, because, and we would say, now, all of our justifications, because we're looking at the graph of g prime, all of our justifications have to be using g prime, okay? So it's because g prime is increasing on, and we would actually write the same exact interval, okay? So -7 to 0, union 2 to 3, okay? And then where are the intervals in which g is concave down? So concave down, we'd have to be talking about g double prime being negative, which in turns tells us that g prime is decreasing. Okay, so g prime is decreasing, and the only place that it's decreasing is from 0 to 2 and from 3 to 5. Okay, so there's actually 2 places. Okay, so g is concave down on, and we would say 0 to 2, union, and they would say 3 to 5. Because g prime is decreasing And it's actually decreasing on those same exact intervals. So decreasing on 0 to 2, union 3 to 5. Okay, so, all right, now the next question is this. All right, so let me zoom out a little bit. Find all x coordinates at which G has a point of inflection. So G is going to have a point of inflection, all right, when G double prime changes signs. Well, that would be where G prime changes from increasing to decreasing or decreasing to increasing, okay? So right here at x equals 0, we would have a point of inflection because G prime is changing from increasing to decreasing, which means G double prime is changing from being positive to negative. So we can't give the actual coordinates of it, we can just tell the location of it, okay? So G has a point of inflection at x equals 0 because G prime, again, everything has to be the reason, the rationale, okay, has to be in terms of G prime. And it's because G prime changes from increasing to decreasing at x equals 0, okay? And then there's another one because now we're changing from decreasing to increasing at x equals 2. So we would say G has a point of inflection at x equals 2 because G prime changes from, and it's changing at x equals 2, it's changing from decreasing to increasing. At x equals 2. And then there's another one at x equals 3 because we're changing from increasing to decreasing, and that would mean the second derivative is changing from being positive to being negative right here at x equals 3. So we would finally say G has a point of inflection at x equals 3 because G prime changes from increasing to decreasing at x equals 3. Okay, let me slide that up a little bit. Now you could have included, you could have put the first sentence and the last sentence together, and you could have said G has points of inflection at x equals 0 and x equals 3 because G prime is changing from increasing to decreasing at x equals 0 and x equals 3. So you can say it like that, okay? But you do need to, this one would have to be separate, this middle one that we wrote, okay? All right. So this is a little summary chart that'll help you summarize everything, okay? So features on the graph of the derivative, if f prime is greater than 0, okay? That would mean f prime is above x-axis. Okay, if f prime is above the x-axis, that tells us that a conclusion we can make is f is increasing. Okay, f prime is less than 0. Okay, f prime is less than 0. That would mean from the graph f prime is below x-axis, and that would tell us that f is decreasing when we see that. Okay, if f prime changes from positive to negative, and that would be from, if f prime was positive, that would mean, if we're looking at the graph, that would mean changing from above to below. Okay, then that would mean f has a relative max. Now, please don't use in your justifications above and below. You can't, okay? But we would say f has a relative max. And if f prime changes from negative to positive, again, that would mean changing from below the x-axis to above the x-axis. Okay, then we would say f has a relative minimum. All right, and then if f prime is increasing, then that would tell us that f is concave up on that interval. And if f prime is decreasing, that would tell us f is concave down. Okay, and I want to go over this. Okay, f prime is increasing. If f prime is increasing, that would mean one derivative way, which is f double prime would be greater than 0, and f double prime for this one would be less than 0. That's a double prime. Okay, and then the last thing, if f prime changes from increasing to decreasing, okay, to decreasing, or decreasing to increasing, that would tell us that f has a point of inflection. Now, I want to say this, okay? If f prime is changing from increasing to decreasing, okay, that would mean, all right, that f prime, if it's changing from being increasing to decreasing, that would also mean f prime has a relative maximum there. And if it's changing from decreasing to increasing, that would mean that f prime has a relative minimum. Okay, so you could also, now you can't give that for justification, but if you look at f prime has a relative max, that would mean it's changing from increasing to decreasing, all right? And if f prime has a relative minimum, that would mean it's changing from decreasing to increasing, which means you have a point of inflection there, okay? So that's just some added features that might help you out to determine, okay?